CBSE Class 10 Math video solution to the sample question paper given by the board for the board examination to be conducted in 2021. It's a basic version of the paper. We are looking at a 3-mark question. This is the first of the 3-mark questions. It's from the chapter Real Numbers, a very easy question. It's a classic proof from the textbook, right? You would have solved this question umpteen times in the class, in revisions, in quarterly, in half-yearly, right? So, you're going to quickly crack this question. You need to necessarily get 3 marks out of this question. Let's get started. How are we going to go about it? In the first 2-3 slides, I'll actually walk you through steps. I'll explain why, what is happening the way it's happening. In the last couple of slides, in a printed form, I'll quickly recap the way we should be writing it in the examination so that we get the full 3 marks for this, right? Let's get started. Prove that root 3 is an irrational number. The first step in this is we're going to assume the opposite. We're going to assume the contrary. We're going to assume that root 3 is a rational number. What we are setting about to prove is that it's irrational. What we are assuming is that it is the opposite, that it is rational. Any rational number can be expressed in the form of a fraction a by b, where both a and b are integers which do not have any factor in common. So, we can express, if root 3 is a rational number, if this assumption is true, then root 3 can be expressed as a upon b, where both a and b are co-prime integers, that HCF is equal to 1. A and b is such that HCF is equal to 1. These are co-prime numbers. Co-prime numbers are obviously integers, right? If root 3 is equal to a divided by b, then we can say a is equal to root 3 times b. I'm going to square both sides of this equation. If I square both sides of the equation, we'll get a square is equal to 3b square. I'm going to call this as equation 1 for our reference. If a is equal to 3b square, b is an integer, which means b square is an integer, then a square is 3 times an integer, which means a square is a multiple of 3. So, from this we can infer that a square is divisible by 3. A square is divisible by 3. A is an integer. If a is an integer and a square is divisible by 3, that's possible only when a is also divisible by 3. So, because a is an integer, because a is an integer, if a square is divisible by 3, then it implies that a is also divisible by 3. If a is divisible by 3, I can write a to be equal to a multiple of 3, which I'll call it as 3c. I'm going to call this as equation 2, where c is an integer. Now, all that we're going to do is we're going to square equation 2 on both sides, right? Squaring 2, what do we get? A is equal to 3c is the equation. We're squaring it. So, what we'll get is essentially a square is equal to 9c square. A square is equal to 9c square. We'll call this as equation 3. Let's go back to the last slide. Check out equation 1. Equation 1 is a square is equal to 3b square. Equation 3 is a square is equal to 9c square. Both in equation 1 and 3, the left hand side is a square. So, a square is on the left hand side, which means the right hand side should be equal. We can equate the right hand sides. So, equation 1 equals equation 3, translating to the fact that 3b square, which is the right hand side of equation 1, is equal to 9c square, which is the right hand side of equation 3. Divide both sides of this equation by 3. So, we'll get b square is equal to 3c square. C is an integer. That's what we said here, right? C is an integer. C is an integer, c square is an integer, which means b square is 3 times an integer. It's a multiple of 3, which translates to the fact that b square is divisible by 3. If b square is divisible by 3, because b is an integer, then b also should be divisible by 3. Because b is an integer, we are writing exactly the same thing that we wrote for a. Because b is an integer, right? If b square is divisible by 3, as it happens here, it implies that b is divisible by 3. B is divisible by 3, then I can say b is a multiple of 3. So, b is equal to 3d, we'll call it as equation 4, where d is an integer. Now, let's compare equations 2 and 4. From 4, we know b is a number which is a multiple of 3, which means b is divisible by 3, right? This is what equation 4 is all about. Let's go to equation 2. In equation 2, which is a is equal to 3c, means that a is divisible by 3. So, essentially from 2 and 4, from equations 2 and 4, we can infer that a and b are divisible by 3. If a and b are divisible by 3, then a and b cannot be co-prime. What was our initial assumption? Our initial assumption is that a and b are co-prime. What we have ended up getting is that a and b have 3 as a factor. They have 1 as a factor, obviously, they have 3 as a factor, which means they are not co-prime. Why is this contradiction happening? This contradiction is happening because of our incorrect assumption that root 3 is rational. Root 3 therefore is irrational. So this is the way to go about it. I'm going to quickly recap everything in a printed form. So the last few words, the last few sentences that I said is also captured for us in a written form, right? So you basically have to write all of the steps that you're going to be looking at down the line, right? From the next slide onwards, whatever we are going to be writing, you need to write all of it to get 3 marks. Let's get started. Quickly recapping. Let's assume the opposite, that root 3 is rational. If root 3 is rational, then we can write root 3 is equal to a by b, where a and b are co-prime. That's their H safe is 1. Which means if root 3 is equal to a by b, we can say a is equal to root 3b. Squaring, we get 3 is equal to a square by b square, or 3b square is equal to a square, right? You can cross multiply and square, or square and then cross multiply. Choice is yours, right? We're going to call this as equation 1. This clearly means that a square is divisible by 3. Because a is an integer, if a square is divisible by 3, because a is an integer, if a square, 3 divides a square, then 3 will also divide a, which means we can write a to be equal to some 3c, where c is an integer. We'll call this as equation 2. We're going to square equation 2. Square equation 2, what do we get? A square is equal to 9c square. We'll call this as equation 3. Go back to equation 1. Equation 1 states that a square is equal to 3b square. Equation 3 tells that a square is equal to 9c square. A square is the left hand side of both equations 1 and 3, which means the right hand sides can be equated, which translates to the fact that 3b square is equal to 9c square. Dividing by 3, we get b square is equal to 3c square. If c is an integer, c square is an integer, then b square is a multiple of 3. B square is a multiple of 3 because b is an integer. If 3 divides b square, 3 will divide b. So b can be written as 3 times d, translating to the fact that b is divisible by 3. And in equation 2, we know that a is divisible by 3, which clearly points to the fact that both these numbers a and b have 3 as a common factor. Note down, you write this step exactly as it is, you will get 3 marks. But this contradicts the fact that a and b are co-prime. This contradiction is because of our incorrect assumption. So assumption that root 3 is rational is not correct, proving that root 3 is irrational, right? So you need to write these steps, write it exactly as it is, you will get full 3 marks, and this is a question in which you should not miss the 3 marks.
Before you leave, I want you to do 2 things. 1, sign up at online.maxtute.com to get started with CBSE Class 10 Math online tuitions. It takes all of 5 minutes and less than 3 steps to get started. And second thing, I want you to subscribe to this channel and turn on notifications so that you get notified every time a new video is uploaded. Spread the word about this channel to your friends and classmates.